Welcome everyone. Today what we're talking about is Physics 20. So we're going to be covering the Kinematics unit. First off, starting with vectors and scalars. So what we're going to be talking about today is what is the difference between vectors and scalars and how to add and subtract vectors and scalars. So what is the difference between a vector and a scalar? Scalars only consist of a magnitude, and vectors consist of a magnitude and a direction. The other main distinguishing factor between vectors and scalars is that scalars are usually represented with a single variable like this. Vectors usually kind of the same letter, but with this little arrow on top. That signifies that it's a vector. So what are examples of this? The scalars, something like distance, speed. For a vector, it would be something like displacement or velocity. So this is in meters, and this is also in meters. Speed is in meters per second, and velocity is in meters per second. The only difference between distance and displacement is direction. The only difference between speed and velocity is direction. So if we wanted to add or subtract scalars, it's something you're already used to. So if we want to add a scalar, so a scalar distance would be something like 2 meters. We can do something like 2 meters plus 3 meters be equal to 5 meters. Nice and simple. Now we do something similar with vectors. Vectors have a direction attached to them. So something like 2 meters to the north or 3 meters to the south. So there's a couple ways to add vectors together. First, we'll start out visually. So if we want to add these two vectors together, this first one we'll call D1 and the second one we'll call D2. And we'll represent D2 in blue. So D1 would be something like this, 2 meters to the north. And then D2 is 3 meters to the south. And so what we actually end up with here is 1 meter to the south. So here we have 2 meters plus 3 meters happens to be 1 meter. And the reason this happens is because of direction. First, imagine you're walking up a block. You're walking 2 meters to the north. Then you turn around and you walk 3 meters to the south. What you end up with is a net displacement of 1 meter to the south. And the way you add these vectors together is you go from tail to tip, tail to tip. So the vector arrow is usually described through two different characteristics. We have this tail here and we have the tip here. You go from tail to tip. That describes what direction you're going in. So just like a compass, this is going straight north. If you wanted to add two vectors together, you go from tail to tip, and then you start at the tip of the previous arrow, and that's your new tail, and then you go in that new direction. And so kind of this net distance right here is 1 meter to the south. The other thing you might be asked to do is subtract scalars and subtract vectors. So if you want to subtract scalars, we'll say 2 meters minus 3 meters. This would be -1 meters. Simple as that. The thing with vectors is we now need to take into account direction. So if we have something like 2 meters to the north, subtracted by 3 meters to the south, what do we get now? So when we added vectors together, we need to go from tail to tip, and then tail to tip. When we're subtracting vectors, we go tip to tip. So we start here, we go up 2 meters, and then the second one we're subtracting. So we need to start at the tip here, drop like here, 3 meters. And so our net distance here is actually 5 meters. So our resulting is 5 meters to the north. So there you have it. That's the differences between scalars and vectors and how to add and subtract scalars and vectors.